Hello students, today let us discuss some of the past paper type questions on the topic of vectors. Now as I already told you, whenever the problem comes, read the problem carefully, note down what things you find important in the problem and write the data with proper symbol. Now here, a particle is initially traveling with a velocity of 3I plus j meter per second along a straight path. See that sometimes even small words give you a lot of hint. It accelerates uniformly at 2I plus 13j meter per second square for 3 seconds. Find the speed of the particle after 3 seconds. So, let us start with this. Now, what things are given to you? The particle is initially moving with a velocity. That means u is given to you 3I plus j meters per second. And as I told you already, whenever the vector is in ij form, write it in column form. That will help you to solve the question more easily. It accelerates uniformly at, that means A is given to you 2I plus 13j meter per second square. So as a column form it is 213 and time is 3 seconds. Now you have to find out the speed of the particle after 3 seconds, and as the particle is traveling along the straight path, the speed is nothing but the magnitude of velocity. So first you will find out the final velocity after 3 seconds. Now, which is the best suited equation of motion here? Your SUVAT equations. U is known, A is known, T is known. You are finding V. So obviously V is equal to U plus AT. So your U is 31, A is 213 and T is 3, which is 31 plus 6, 13 into 3, 39. Now add component wise, 6 plus 3 is 9, 39 plus 1 is 40. And since the particle is traveling along a straight path, the speed is the magnitude of the velocity. So speed after 3 seconds will be the magnitude of velocity, which is root of 9 square plus 40 square, and that will come out to be 41 meter per second. You have to directly do that on the calculator. Okay, so come to the second question here. Again, read the question carefully. The particle is moving with a velocity I plus 2j meter per second along a straight path. It accelerates uniformly at 2I minus j meter per second square for 4 seconds. Find the distance traveled by the particle in 4 seconds. So let us write the data. The particle is moving with velocity. That means the initial velocity is given to you I plus 2j meters per second. So write that as a column vector 1, 2. It accelerates uniformly A 2I minus j meters per second square, that is 2 negative 1, and you have to find the distance traveled in 4 seconds. Now since the particle is traveling in a straight path, the distance is the magnitude of displacement. So first of all you have to find out the displacement. So which is the best suitable equation of motion here? U is known, A is known, T is known. So S is equal to ut plus half at square. Ut, that is 1, 2 into 4, half a 2 negative 1 into t square. 4 square is 16. So first you multiply the first column vector by 4, that will be 4, 8. Then here first you multiply this half with 16, that is 8. So 2 negative 1, that is 4, 8. Do this scalar multiplication, 8 2s are 16 and minus 8. Now add these two column vectors. So 4 plus 16 is 20, 8 plus negative 8 is 0. So I can say that displacement of the particle is 20 meters. And since the particle is traveling in a straight line, the distance traveled by the particle, so distance traveled by the particle in 4 seconds will be square root of 20 square. Obviously there is no j coefficient, so 0 square, which comes out to be 20 meters. So the distance traveled by the particle in 4 seconds will be 20 meters. Okay. Now let us come to this next question. A boat is initially at a point with position vector 2I minus 2j meters. It starts moving with a constant velocity of 10I minus 5j meter per second. At the same time, a yacht is at a point with position vector 5I minus 4j meters and starts moving with a constant velocity of 9I minus 4j meter per second. If both of them continue the same path, you have to show that they will collide. So I'll just explain this by drawing a simple sketch here. So suppose the boat is initially at some point here and then it is moving with a constant velocity, say in this direction. It comes to some point A here. Now yacht is at some point here and it is moving with a constant velocity. Now if both of them will collide, then what will happen? The final position vector of both boat and yacht will be the same. They are going to meet at a point. So the position vector of the final point will be the same. So if I can show that the final position vector for the yacht and the boat is same, then I can prove that both of them are colliding or meeting each other. So first let us take for the boat. The initial position vector is given to you. The initial position vector of the boat is 2I minus 2j meters. 2I minus 2j meters, which in the column form I will write it as 2 negative 2. The velocity, the constant velocity of the boat is known to you. The boat is moving with a constant velocity 10I minus 5j. 10I minus 5j meters per second. So, which is 10 negative 5. So, let me find out the final position vector of the boat after say t seconds. So, I will take it as RA. So, RA will be R0 plus Vt R0, that is 2 negative 2 V 10 negative 5 into T. So this will be the final position vector of the boat after T seconds. So 2 plus 10T and minus 2 minus 5T. Now let us consider the motion of the yacht. Now for the yacht, the initial position vector R0, the initial position vector for the yacht is 4I minus 4j. 4I minus 4j meters, which is 4 negative 4 as a column vector, and the constant velocity vector for the yacht is 9I minus 4j meter per second. So suppose RB is the position vector of the yacht after t seconds. So that will be, again use R0 plus Vt formula. So R0 4 negative 4 plus V 9 negative 4, V as a column vector is 9 negative 4 into T. So this is the position vector of the yacht after a time of t seconds. Now, if the boat and the yacht collide, if the boat and the yacht collide, that means the final position vector of the boat and the final position vector of the yacht should be the same. Let us equate these vectors and solve and check whether that satisfies. So 2 plus 10t minus 2 minus 5t. Obviously, if the yacht and the boat will collide, after solving this, I will get the same value of t. That means the vector is getting satisfied by a single value of t. So let us see. First let us equate the x components. 2 plus 10t is equal to 4 plus 9t. So 10t minus 90 is t and 4 minus 2 is 2. Similarly, if I equate the y components, what I will get? Minus 2 minus 5t is minus 4 minus 4t. Now minus 5t plus 4t, that is negative t, and minus 4 plus 2, that is negative 2. So as you can see, the same value of t is satisfying both the components. That means at t is equal to 2, the final position vector of the boat and the yacht will be the same. That means if the boat and the yacht continue the same path, they will collide. They will collide after 2 seconds of the starting of the journey. So come to the fourth question here. Forces F1. F1 is 2I minus 3J newtons, which in the column form 2, negative 3. Then another force F2 is the I minus 2J newtons, which in the column form 1, negative 2. And the third force F3 is 4I plus J newtons, which is in the column form 4, 1. Now, these three forces are acting on a particle of mass 2 kg. We have to find out the acceleration of the particle. So first we'll find out the resultant force F. Now what is the resultant force? Resultant force is the vector sum of all the forces acting on the particle. So that will be F1 plus F2 plus F3. So that is 2, negative 3 plus 1, negative 2 plus 4, 1. And that is 7, 4, 2 plus 1, 3 plus 4. That is 7 minus 3 minus 2 minus 5 plus 1. That is negative 4. So the resultant force is 7I minus 4J newtons. So whenever a resultant force acts on the particle, what happens? The particle will accelerate. So by Newton's second law, F is equal to m into A. So that is 7 minus 4. M is the mass of the particle, 2 kg into A. So A will be, take 2 on the other side, 7, negative 4. Now multiply each component by half. So 7 upon 2 and minus 4 upon 2, that is negative 2. That means the acceleration of the particle will be 7 upon 2I minus 2J. So these are some of the past paper type questions on vectors. We'll solve few more questions on the same topic in next few classes. Okay, so go through these concepts. Wish the steps are okay with you. See you in the next class. Enjoy the day. Bye.